This is the solution to problem number 63 from section 7.1. We're asked to perform multiplication and use fundamental identities to simplify. So we have fractions here that we need to add. In order to add fractions, we need a common denominator. So the common denominator for these two fractions is actually the quantity 1 plus sine x times cosine x. So I'm going to multiply the first fraction by a funny form of 1, which is cosine x over cosine x, because cosine x is what's missing from the denominator of the first fraction. And I'm going to multiply the second fraction by a funny form of 1, which is 1 plus sine x over 1 plus sine x. Once I do that, both fractions have the same denominator, which is cosine x times the quantity 1 plus sine x. So now the first fraction becomes cosine squared x over cosine x times 1 plus sine x. And don't multiply out the denominator to the end, because maybe we can cancel out some expressions or some factors. And the right fraction becomes 1 plus sine x quantity squared over cosine x times 1 plus sine x. And now I'm going to add the two fractions. So I'm going to have cosine squared x, and I'm going to expand 1 plus sine x squared, which is 1 plus 2 sine x plus sine squared x, all over cosine x times the quantity 1 plus sine x. In the numerator, you'll notice that we have cosine squared x and sine squared x, and by the Pythagorean identity, we know that sine squared x plus cosine squared x is equal to 1. So I can actually substitute 1 in. So I have 1 plus 2 sine x all over cosine x times 1 plus sine x. And 1 plus 1, I'm going to add combine like terms in the numerator. So this is going to become 2 plus 2 sine x over cosine x times the quantity 1 plus sine x. And then the numerator I'm going to factor. This is a rational expression, and perhaps we can cancel something out. So I'm going to factor out the greatest common factor, which is 2 from the numerator, leaving me with 1 plus sine x over cosine x times the quantity 1 plus sine x. And now 1 plus sine x actually cancels out, leaving us with 2 over cosine x, which is equal to 2 secant x. And we should actually put in, we know that when we cancel out a factor, we need to say 1 plus sine x is not equal to 0, which means that sine x is not equal to negative 1. I don't know if the textbook has that. The textbook probably just has 2 secant x as your answer.